Hello, welcome to Staring Down the Storm, Autism Advocacy in America. I'm your host, Tabitha Ziegler. All right, everybody, welcome back to the podcast. We've got a very interesting guest today. We've got Barbara Busolo.
Thank you. Thank you for having me.
No problem. So introduce yourself a little bit to everybody. Give us your origin story.
Sure. So I always said I'm originally from Argentina because this accent is not going anywhere. Moved to United States in 2000, married, someone from United States, and then moved to here, Carmel, in 2008.
Okay.
So I moved here to run a company called RCA Thomson Technicolor. And I ran that company for like 10 years. And then after I ran the company, I moved to my own company.
Okay.
And now I own an AI company called Dynamo Edge.
Okay. Perfect. So walk us through a little bit about your educational background whenever it comes to technology.
Yeah. So I have a master's in inorganic chemistry. I don't know why, because I like inorganic chemistry for some reason. But when I moved to the United States, I started working in a company called PerkinElmer that is doing all the analytical instruments, electronics, and that was kind of my crossover to electronics.
Okay.
And then obviously Technicolor, I gained a very heavy telecom background because Technicolor, like I was the president of the company and we were selling those boxes that will give you internet at home. So connecting things, right? And for me, I always see things as a connected home, which is what I ran for many years. And one of the main problems in Technicolor was that they were returning us those devices and they didn't have any problem. So I was kind of obsessed with like fixing that. And the only way to fix it was by being able to predict what's going to happen with that machine and then trigger an action for that thing not to happen. And that's what my AI does. And we have AI patents, etc. So we became the first AI able to predict what is going to happen in a race car.
That's very interesting, especially because we have a Indy racetrack here.
Actually, we did it with the Andretti team. We helped Andretti to go to Formula One.
Interesting. Okay. So let's talk with everybody a little bit about Formula One, because for those that don't know what Formula One is, let's explain that a little bit to them.
Sure. So in Indianapolis, in Indiana, we have a racing series, right? A tournament called IndyCar. So IndyCar is the largest series in the United States, but there is one series that is even bigger than IndyCar, and that is Formula One. So Formula One, now it runs in US. I think after like 2 years ago, if I remember correctly, they have races here, started in Miami and Vegas, and they're going to have more. And the main difference between Formula One and IndyCar is that the cars are the same. The Dallara chassis, Dallara is the company that makes those cars. It's pretty much the same. But then inside, the electronics are different. In Formula One, they're much more complex. And the main difference, to like oversimplify everything else, is that the Indy car is 15 years old. The Formula One car, there is one new car every year.
Oh, wow. That's very interesting. So walk us through how you came up with this idea to make things function in the car in a more efficient manner.
So for me, remember when I said, for me, the car is like a connected home. That's my background. The only difference is that car moves. So it's like a home moving, right? And I knew that if I wanted to predict that problem or to fix that problem that we had in Technicolor of predicting what was going to happen with a machine, a car was another machine. And back then, Michael Andretti wanted to have a company with me that did this type of things. So I went with him to AT&T and I introduced him to some, very good friends and contacts that I have from my Technicolor days, because I was seeing that he was not understanding technology and that he was not going to be able to compete in Formula One with the type of sponsors and the type of technology play. Remember, 15 years old versus one car every year. So very different leagues in terms of technology. So I started to teach Michael technology, and we ended up, when we went to AT&T, the person in AT&T said, why don't you do it with race cars? So prove me with race cars that you can predict what is going to happen and you can trigger an action. So if in real time you can predict when that car needs to pit again and why, I'll invest in your company. So we did it with race cars. AT&T invested in my company, and then we repeated the same with that investment of AT&T for commercial cars. So now we have a contract with the Indianapolis Fire Department where what started in race cars is now running in heavy trucks in Indianapolis.
Okay. So because we had a conversation before about this, and I'm just trying to make it very easily digestible to the listener. So what type of things within the race car or within the fire truck would your company work on to improve those type of things?
I see the car as I see a home. So in the home, you have telemetry. Telemetry is data that is moving, right? Like you have the internet that moves the data. And then inside of that internet, you have the data that is being moved. So what we did with cars is to actually create what is called a digital twin. It's a very fancy word to say that we extracted all the data coming from the sensors of the car. We don't care who the driver is. We don't care if you have a cell phone, don't have a cell phone. Like we don't even know who the person is at all. But what we measure is the performance of those sensors. So we create that digital copy of that thing, of that car, of that home, of that whatever it is. And then we start analyzing all the sensors at the same time. That's something that you can do with AI, that without AI you couldn't. But it has nothing to do with the AI that most people talk about, which is something called LLMs, which is large language models.
Okay.
ChatGPT, OpenAI, Claude is a large language model. So they're very good to predict words, but they have no clue who you are. They have no clue of your sensors. If you ask ChatGPT, what do I need to do to be more efficient in the way I drive? ChatGPT is going to tell you most people, drive slower and whatever. But they have no clue. They're going to tell you an average of everybody else. Now, what we do is we actually measure those sensors and we start telling drivers in the next 1,000 miles, stay at this speed, don't idle for more than 3 minutes, and put 3 PSIs in your right front tire, and you're going to be able to save this much money, this much energy, and this much CO2. CO2, carbon dioxide is important. Why? Because we have a contract with Bank of America that once we get to 1 ton of CO2, we sell it as a carbon credit. That means that whomever uses the software can, number one, save money, and number two, make money.
Wow. Well, I think a lot of people are really curious about AI data centers right now in Indiana because, as we're aware, Mike Braun just put out an announcement that we were going to have a huge metadata center, I believe is what he said. So I drive back and forth between Indianapolis a lot. And I've noticed over the past few months that there's been a lot of bulldozing, a lot of leveling of the land. It was clear that something was going in there. So I think anybody that was driving that route knew something was coming. And it is miles and miles of land. So when you're talking about an LLM versus regular AI and the differences in between, and you're saying that there is a cost comparative and savings, walk us through what that may look like with an LLM with that much land.
Yeah. So LLMs are neither great or evil, right? It's one category of AI. AI is a mathematical equation that someone needs to write. And then basically what that mathematical equation does is it repeats itself. So that's where you need the computing portion, right? So LLMs are great if you want a chat box. If you want a chat box that understands Wikipedia. But every time you run that chat box, it's going to go through the whole database of Wikipedia to make it like super simple.
A to Z.
So that's what it uses as a data source. So it's going to consume a lot of energy, tons of energy. But LLMs, again, they're good for some things if you want to chat, a chat box, but they're not good for other things which are called the real world AI, which is what we do, which is not talking, but actually looking at the telemetry of machines and then predicting good or bad things with that telemetry of machines. So what you see in the Leap district, where there is a big, Eli Lilly factory or Eli Lilly place, let's call it. And now I've heard also that there's going to be a meta data center. I believe that for what I've heard is mostly for OpenAI and LLMs. That means it's going to suck a lot of power. And the problem in the market right now, that AI bubble that everybody is talking about, which I fully agree because I couldn't understand what was going on for years, is that there's no demand for all of these things. So all these AI companies, they started creating infrastructure, which for me, excuse my language, is a big BS, because every time you have a new technology, you need a new place to run it. You need a hard drive, right? But in your house, you don't go and you pay 10 years of electricity in advance just in case you run out of gigawatts. So what this AI bubble is a group of very large companies with a group of very large private investors that are making us believe that we're going to need all that compute. So they took about $1.7 trillion in debt, but there is no product. So there is no product that is going to pay for all that money that they borrow in advance. And they borrowed in advance to create these data centers to secure the gigawatts. There's nothing to be secure because there's no demand. So until we know how that 1.7 trillion, give or take, are going to be returned, I mean, there's no demand. Are you going to pay $30 a month for everybody in your family starting in 2-3 months so that, you know, OpenAI and Palantir and NVIDIA and all these people can pay their dividends? What product? Like, what is it that they're going to sell us that is going to consume all that electricity?
Well, just to start, I think people are, especially rural communities, where is generally where these places are going. They're more curious about, at present, the consumption of energy, the consumption of resources, how much water it's going to take to cool these places. So when you're talking about a lot of resources, paint a picture for people of what that may look like. Because from what I understand, this current data center that's going into Indiana would be the largest in the country. Is that correct?
I have not looked closely into the particular Meta one. I know that the NVIDIA factory is the largest in the country.
And that's going to be based in Lebanon?
Yes.
Okay.
Yes. They call it an AI factory. It's supposed to be a Eli Lilly foundry. And it's called Foundry because it's a customer of a company called Palantir Foundry. So Foundry is the database of Palantir. So everything that you hear Foundry, your data goes to the database of Palantir. I've heard and I've seen some numbers where we're going to need more electricity than the one we have, which is absolutely insane. So, I mean, for me, none of this makes any sense, right? Because you're creating a ginormous demand for electricity when there is no product behind. So for that, yes, the data centers need utilities. So they need water, they need construction for internet, they need all of the things that today are not there. And all of the things cost money. So it blows my mind why they want to have all these things ready, shovel ready, when there is no product. So no one is really wondering, okay, we give data centers this, 50 years of tax breaks. What comes out of it? You know, because at the end of the day, if I understand correctly, basically the large companies are having a tax break for a very, very long amount of time. Basically, the equipment is also not producing results, not producing revenue in terms of taxes, because it's also, I'm not going to say words that I don't know exactly what, but it's also like, you know, protected is not the right word, but you know what I mean? It's so at the end of the day, the only one that wins here is two people, the data center and whomever brought, you know, with them, and locally, the people that are building the utilities, because you need a new network, because all of these things are connected to the internet. You need to extend the U.S. energy grid, which is another discussion because it goes to the ether, but let's assume that the energy grid goes somewhere. So you need all of these things for a data center to then come. And for what I understand, the way Indiana is doing it is going to the farmers, the landowners, and they're leasing their farms, their land, for a very long amount of time. But the problem is that if for whatever reason, the company that is leasing their land default in payments, no one really knows what is the collateral. And I'm not a lawyer, but let's just say there is a risk that the collateral is the farmer.
So let's walk into that a little bit more then. So for your typical farmer, maybe they say have 100 acres of land, which would be considered a small hobby farm around here. How would this approach go? How would this transaction go for someone to approach this farmer and say, listen, I want to rent your land for the next 40 to 50 years. What's the exchange? What's the contract? Like, how does that how would that scenario play out?
So what I understand is that I know some people that went through that process. Obviously, I didn't go through that process myself. So I'm just going to repeat what I've learned from others. So someone will come to your house with the name of some legal entity. There's several legal entities, and then will come and knock on your door and basically said, I want to rent your land. And then they will offer you a contract where you cannot talk about it. And then that contract says, I'm going to lease your property for, let's make it 50 years, right? It has a term. And then in exchange, you're going to keep the title of the property. So the property is going to be yours. The land is going to be yours. And you're going to pay whatever mortgage you have in that land, if you have anything to pay. But I'm going to pay you. So say you have to pay $10 for your land. I'm going to pay you 12. So you keep 2 and then you pay 10 for your mortgage. So that happens, or that continues for like, say, 50 years. And the lease owner, meaning that company that came and knocked on your door and say, I want to buy your land, they had the right to basically do whatever they want with the land, utilities, run water, electricity, and also a huge right, which I really would like to understand where that money is, which is they have the right to monetize the carbon credits of that land. The carbon credits of that land means, apart from the tax subsidies, there is another program where if you run clean electricity, you can also generate money. The only difference is the way we do it. First of all, we save electricity, we don't add more, and we give the carbon credits to the company, to the people, to the whomever is the owner of that land. We have a project in Peru that is similar to that. Peru has a lot of small farmers. So what they want to do is they want to incentivize the farmers to have, more money to do more things, but they don't take their property. So we have a software that parcels the small, farms, and then we know exactly how much carbon credits each small parcel is creating. And then the administrator of the program, which in Peru is the government, pays them back, but is extremely transparent. So the landowners, if in Indiana they're paying you $12, okay, if you actually keep the carbon credits, those $12 become $50. So there's someone here that is keeping a big, change.
Larger chunk. So therefore, essentially, there are entities that are being less transparent than they should be with these farmers. So when they approach them, they already know this extra information that they're,
of course,
purposely withholding from these farmers.
Of course they know. Not only that, but there's something that, again, like, I'm not a lawyer, but I'm a logical person, and that really concerns me, that there is an organization called the Indiana Economic Development Corporation, which is the one that is kind of sending those legal entities that then come and buy your land. And the problem with that is that if you look at the contract of the Indiana Indiana Economic Development Corporation, there is a clause there where that NGO, that is a semi-something, quasi-something, where, depending in what activity is it, one day they're private, one day they're public, one day they're us, one day they're ether. But what they did is they created one more legal entity in between, and they don't use the name, they use an intermediary. The intermediary is called IIP LLC. We don't know why. Like, I don't think someone woke up one day and say, let me create a random legal entity and randomly I'm going to call it IIP LLC. That IIP LLC has a reason for being called IIP LLC. But the name is not the problem. That will be the person that knocks on your door, right? The problem with that is that that company, IIP LLC, that is created on purpose to be the intermediary between the government and the landowners, has a little problem in their contract, because it's a public contract. Anyone can go into the IADC transparency portal and just Google, like what I'm telling you. The contract is under a legal firm called Taft, TAFT, I believe. And that company opens that IIP LLC legal entity and remove all the liabilities from the IADC. It's the public contract. So they remove all the liabilities for taxes, for lawsuits, for everything. So basically, remember when I said if something goes wrong, who is the collateral? If I don't pay you those $12 and I'm IIP LLC, you're going to come to me, right? And you're going to say, where are my $12? I'm going to pull that contract and I'm going to tell you I'm not responsible for it. What are you going to do?
Interesting. And the little bit of research that I've done,
Mhm.
it would seem that the IEDC is funded by taxpayers. Is that correct?
100%.
Okay, so we're talking about 100% financial backing from the taxpayers that are not exactly clear on a very large project that is going into Indiana, that they are also unaware of what the potential output would be, where these resources will be going, what amount of utilities it will require, what those increases will be, what that will look like for the residents.
Yes, essentially, yes. And there is one more caveat to that, which is also dangerous. There is a company called NIPSCO that is, the one like moving the energy, let's say simply. And that company created another company inside of themselves called Genco. And that Genco company can sell the excess energy of all these grid that we're building for some customers that eventually will come. They can sell it to private companies. So say that everything that we're building here has no demand, right? So everything is excess. Well, the people from Genco can actually resell that energy that we all paid for with our taxes to Eli Lilly, to Meta, and they can make money out of it.
Interesting. Well, I think we'll stop there for now. That's just a little bit of a taste of this series that we're going to be walking into with our friend Barbara here. And we're going to be diving into a whole series about AI and how AI impacts Indiana and Hoosiers. And you guys should stay tuned. We'll see you soon.
Thank you.
We are at a pivotal point in American history. We do not have the luxury to remain silent. Programs are disappearing every day. We hope that this podcast raises awareness and sparks a sense of advocacy in you. We all can make a difference. The important thing is to start. See you next time.